Hi, and welcome to another lecture. This time we're going to talk about pipeline parallelism in SimpleFSDP. So what is pipeline parallelism? The basic idea is that you're going to take your very large model and then you're going to split the model by layers across multiple GPUs. So here, you have the most simple, where perhaps you split the first fourth of your model into one GPU and then next and whatever, and then when you run your forward pass, you go through the first GPU, the GPU does some computation, passes the result to the second GPU, etc. And here we can see a bunch of pipeline schedules. So here's the simplest, where you basically do all your forward passes, and you'll notice that these are kind of small boxes. In pipeline parallelism, we would do what's called microbatches, where we split up your batch into smaller batches, and then we kind of run them through the pipeline. And so this is the simplest one, where you do forwards and then you're backwards. This one is called 1F, 1B. And what this does is it starts to do the backwards earlier. All right, so notice how you wait for all of the forwards to finish, and then you do the backwards. This one you can kind of do the backwards earlier. You'll notice that it actually doesn't necessarily make your end-to-end runtime faster, but it does save on memory. And this next one's called 1F, 1B interleaved. And the idea behind this one is to make your make the layers not necessarily contiguous. So the basic idea is GPU 1 might run the first layer, but it might also run the fifth layer. And so you can see here that, the microbatch 1 goes like the GPU 1, GPU 3, 4, and then comes back to GPU 1, 2, 3, 4. And so you get some efficiency improvements this. And then this last one is called dual pipe, which was invented by DeepSeek. So you'll see this dual pipe thing. But one of the most interesting innovations behind this is this insight that whenever you're doing backpropagation, you're typically calculating two gradients. You're calculating one gradient with respect to the parameters of your model, and then another gradient with respect to the input. And the gradient with respect to the input is much more important from a scheduling perspective, because this blocks the backpropagation from the rest of the graph. Whereas this one, in theory, you can schedule at any time. And so this is where you see this backwards for inputs and backwards for wait thing. Where backwards for wait is this almost trump card, where you can just insert it flexibly, and you want to more eagerly do this backwards for input. And so this gives you an even nicer pipeline schedule. Okay, so now let's look at the code. So all of Torch Titan's pipelining, at least for LLMs, happens via this pipeline LLM function. And there's a bunch of stuff that goes on here, but the most important part is here, where we do a pipeline module split, where we take our model and then we split it into stages and model parts. And that corresponds to these stages in these pipeline schedules. And then using those stages, we build a schedule. So this figures out, which microbatch to schedule on which device when. And then we return the PP schedule. Now, if we go to the trainer in the forward-backward step, we can see that if pipeline parallelism is enabled, we do this self.pp schedule.step. And what this will do is this will do an entire batch worth of work. So indeed, if we go here into the step function, you'll see that we split the input into microbatches. We run through the microbatches, and then we merge the output. And then that gets put into losses, and then you do your loss calculation, et cetera, et cetera. So hopefully this was a good overview of pipeline parallelism. There's definitely a lot of intricacies, which maybe I'll go to in a future lecture, but this should give you a good starting point to understand what's going on and give you a few good code pointers in case you want to dive in deeper. Okay, see you in the next lecture.